Quantity of mass. Atoms are too small to count, but the chemist must count atoms for atom in any chemical reaction. Measuring mass is straightforward. The dilemma is that the mass must be concisely related to the number of atoms in the chemical formula so that the correct number of reactants and atoms are used. As we have learned, each atom has a specific mass primarily determine the number of nucleons. So when we look at the periodic table, we see the atomic number and atomic mass specified for each element. So based on that atomic mass, based on how many such atoms we have, we just multiply or we add those many numbers and we find out the mass of each atom or each molecule. So the mole. A mole of any element is the amount of it whose mass in grams is equal to its atomic mass expressed in atomic units. So in other simple words, if you express any materials or any element's atomic mass in grams, that is equivalent of its 1 mole. So for example, oxygen's atomic mass is 16. So if you ask for how much is 1 mole of oxygen, it is nothing but 1 mole of oxygen is 16 grams. And if you look at the carbon's atomic mass is 12. And if it is 1 mole of carbon, then it is nothing but 12 grams. 1 mole of carbon is 12 grams. So the unit of mole is abbreviated as MOL. Another way of thinking of this quantity is a mole of any element contains the same number of atoms as a mole of any other element. So if you are looking at 1 mole of oxygen or if you are looking at 1 mole of carbon, the number of atoms in that mole would be exactly same. If you are looking at 1 mole carbon dioxide or if you are looking at 1 mole of water or a mole of oxygen, if you look at the number of atoms in it, it would be exactly same. And that number is nothing but an Avogadro number. And how many atoms per mole? It's going to be 6.02 times 10 to the power 23. And we abbreviate it with the N0. And this is the number of atoms in a mole. And this is a constant number. And it is also called Avogadro's number. And that number is 6.02 times 10 to the power 23 atoms per mole. So if you look at any molecule or any material of 1 mole quantity, you will have exactly the Avogadro number quantity of atoms. Computing the number of atoms. Knowing the atomic mass and the Avogadro number, we can compute the number of atoms in any amount of a substance. Given a mass of a substance, you can determine the number of moles, and that is by number of moles is equal to mass of the substance divided by molar mass of the substance. Then using this N0, we can compute the number of atoms. So number of atoms would be moles of the substance times N0. So for example, as we already talked about, if you are looking at the carbon atom, so the mass of the carbon atom is 12 units. So 1 mole of carbon is nothing but 12 grams. Another example is atom of oxygen. And if you look at the mass of the oxygen in the periodic table, it is approximately 16 units. So if you are asking about 1 mole of oxygen, that would be nothing but 16 grams. How many atoms are there in 100 grams of iron? So for example, I want to show you how you are going to get the number of atoms in any given quantity of any material. So this is an example. How many atoms are there in 100 grams of iron? So first we need to find out how many moles is that when we call about 100 grams, because we already know that 1 mole of iron will have 6.02 times 10 to the power 23 atoms. But we don't know how many grams is that. So first we need to find out how many grams is that. Or we can find out if we already know that iron, 1 mole of iron is nothing but 55.85 grams. Then how many moles would that be if it is 100 grams of iron? So that's why I need to find out if this 100 grams would be how many moles. So in order to do that, so moles of iron is nothing but mass of Fe, which is iron, divided by molar mass of Fe, which is iron. So most of mass of iron is given as 100 grams. And then when you look at the periodic table, you can find out the mass of this iron, which is as 55.85. When you do the math, you get 1.79. So when we call 100 grams of iron, it means it is equivalent of 1.79 moles. So now we know that each mole of iron will have 6.02 times 10 to the power of 23 atoms. So we know that we have 1.79 moles of iron right here. So how many moles that would be? So all we need to do is the simple math, which is 1.79 times 6.02 times 10 to the power of 23. Then we get that it's almost close to 1.08 times 10 to the power of 24 atoms. So if you give 100 grams of iron, it will have so many atoms of iron present in there. Formula units. So if we want to find out the mass of let's say an element carbon or element hydrogen, element nitrogen, then simply you can look at the periodic table and find out the mass of it. But how about if I say carbon dioxide, if I say water, which is H2O, or if I say H2SO4, how would you find out the mass of it? So if you want the finding of the mass of the chemical formula is called formula mass. We can extend the idea of moles to the compounds also, not only just the elements, but also you could extend the idea of the moles to the compounds also. Let's imagine like we are talking about being carbon atoms being something like we just did the example, that is 100 grams of iron. We found out how many ions will be there in that 100 grams. In the similar fashion, we can say if we have like 20 moles of water, how many atoms will that be? We could find out too. So in that particular compound molecules, how many will there be? We could find out using the same concept. For a single element like iron, iron atom has a mass of 55.85 units. 1 mole of iron has a mass of 55.8 grams. So this is how we express 1 mole. 1 mole means its atomic mass expressed in grams. So 1 mole of iron is 55.85 grams. So if you're looking at a compound such as carbon monoxide and its chemical formula is CO, if you want to find out the mass of CO, so you can see that you have 1 carbon, 1 oxygen. So find out from the periodic table, 1 carbon mass is 12 units and 1 oxygen mass is 12 units. So 16 units, sorry. So when you add these two, you get 28 units. So the mass of CO, which is carbon monoxide, is 28. And 1 mole of carbon monoxide has a mass of 28 grams. Since atomic mass expressed in grams, 1 mole of carbon monoxide will be 28 grams. So this is also called the formula mass of carbon monoxide is 28U. The formula mass of a substance is the sum of atomic masses of the elements it contains, each multiplied by the number of times it appears in the formula of the substance. Let me give you an example. If you're looking at NaCl, so you see that you have sodium there and you have chlorine. So if you are trying to find out the formula mass of it, you have 1 sodium, 1 chlorine. You look at the periodic table, find out how much would that be, 1 sodium. So it would be 22.9. 1 chlorine is 35.45. When you add these two, then you get 58.44, and that is the formula mass of the sodium chloride, which is NaCl. Another example, you have Na2SO4. So in this case, how many sodiums do I have? I have 2 sodiums, 1 sulfur, and 4 oxygens. Based on that, I'm going to find out each sodium would be 22.99. Like that, I have 2 sodium. So 2 multiplied by 22.99, which gives me 45.98. And I have 1 sulfur. So 1 times 32.06 gives me 32.06. And 4 oxygens. 4 times 16 units. It's going to give me 64. So when I add all those, then I get 142.04. So the formula mass of the sodium sulfate is 142.04. Na2SO4's formula mass is 142.04. How many grams of oxygen are needed to burn 100 grams of propane? So one of the examples again to find out how many moles will that be and how we are going to make use of this moles concept. Here, when you write the equation of this combustion, so propane is C3H8 and plus 5 oxygen gives you, when you combust the propane with oxygen, it gives you carbon dioxide and water. So when you balance this equation, you will see that C3H8 plus 5 oxygens gives you 3 carbon dioxide and 4 water. So the number in the front of that each chemical compound is telling us how many moles of each thing is, such as it is 1 mole of propane, 5 moles of oxygen reacted together to give 3 moles of carbon dioxide and 4 moles of water. So in any chemical reaction, when we balance, the numbers in the front, the quotients in the front are giving you the information of how many moles of each thing is. So now we are trying to find out the formula mass of oxygen. So how many oxygens we have? Like O2. So 2 oxygens gives you 32. The formula mass of C3H8, this gives me, I have 3 carbons, 8 hydrogens. So 3 carbons, so 3 times 12 gives me 36. I have 8 oxygens, so it gives me 8 times, each hydrogen is 1, so it gives me 8. So if you find out the total, so C3H8 formula mass is 44.06. Then I saw that I have C3H8 plus oxygen is giving me carbon dioxide as well as the water. So I'm trying to find out moles. So I know that each propane is added to 5 moles of oxygen to give me 3 moles of carbon dioxide. So I'm trying to find out how many moles of propane is that, which I'm adding it to the reaction, because they said it's 100 grams. They did not mention how many moles is that. So we need to find out how many moles is that 100 grams. So mass of C3H8, actually this should have been C3H8. And so that is 100 right here. And then the molar mass of C3H8, it should have been H8 right here. So it's 100 over 44.06. That gives me 2.27. And moles of oxygen is 16 and 16 divided. So we know from this equation right here, each mole requires 5 moles of oxygen, right? So like based on that, so each mole of propane is used to, each mole of propane needs 5 moles of oxygen. So, and like that, we have here 2.27 moles of propane. So how many moles of oxygen would that be? So that's going to be moles of oxygen divided by moles of this times moles of propane given. So that's going to be 5 times 2.27. That's going to give you 11.35. So if we were taking 1 mole of propane, it needs 5 moles of oxygen. So here, since we are taking 2.27 moles, we need 11.35 moles of oxygen to burn that 100 grams of propane. So if you want to find out how much mass is there, since we just know the answer in moles, we need to find out how many grams is that if we want to find out the mass of it. So moles of oxygen, which is 11.35, and each mole of oxygen is 32 grams. So if you multiply these two, so for each 100 grams of propane, we need to add 363 grams of oxygen to do the combustion, complete combustion.